this video, we're going to look at the practical problems where we use integration, and it all has to do with definite integrals. Right at the start of our integration videos, we said there are two types of integrals, indefinite and definite. Indefinite is when the integral sign has no little numbers above or below it, and definite is when there are little numbers there. So what do we do with these numbers, and what do they mean? Let's look at the example. In the example, we can see it's a definite integral because it has the little numbers 1 and 5 attached to it. The good news with definite integrals is that we still do integration exactly the same way as with indefinite integration. We'll only use those little numbers right at the end. So let's integrate as usual. Step 1, preparation. Split the terms, remove the coefficients, and add x to the power of 0 to any term that doesn't have an x. Once that's done, we check if we have a key to do the integration. We can immediately see that for both parts, we can use the normal power key. Look carefully at how we carry the little numbers along. They stay with the bracket until we've finished integrating. When we simplify what we can, we're left with this answer. Very important, with a definite integral, when we have these little numbers, we do not add plus c. Now for the next step, we use the little numbers. We substitute the top number, which will always be the larger of the two, into our integrated answer first, then we minus, and then we substitute the bottom number. It always follows that order, and there is always a minus in between. Working it out, we get 61.33 as the answer. But what does this answer mean, and what does it have to do with practical problems? Now, what this answer means becomes clear when we sketch the function they gave us to integrate. If we sketch the function between the little numbers that come with the integral, it looks like this. Here's the meaning of integration. It gives us the area between the function and the x-axis. So the shaded region between 1 and 5 is exactly what our integral refers to, and we've just worked out the area of that shaded region as 61.33 square units. That's the practical application of integrals. It's about area. Now, an important distinction to make between areas we compute with integration is the difference between net sign area and total area. Let's take the following example to see the difference. It will follow exactly the same steps as our previous definite integral example. Step 1 is to split the terms, remove the coefficients, and add x to the power of 0 to every term that doesn't have an x. Then we use our normal power key for integration and get the following answer. The last step is to incorporate the little numbers. We substitute the top number into our integrated answer, then minus and substitute the bottom number. When we evaluate, we get negative 85.75 square units. This answer is our net sign area. It feels strange to get a negative answer for area, and that is exactly why there's a difference between net sign area and total area. Now let's look at the same integral and compute the total area. And you'll see that this weird negative area will make sense. The full video is only available to our awesome ebook course students. In our ebook course, all your videos live in one place, together with the ebook and downloadable cheat sheets. No more 2 a.m. doom scrolling on YouTube before a test. Everything's in one spot to help you succeed at Calculus 1 the first time. Let's be honest, I'm not here to convince you of the beauty of calculus. I'm not a professor who can talk for 3 hours about how elegant differentiation is. This is damage control to get you through Calc 1 so you can move on with your degree and with your life. This is your please don't ever make me redo this class again plan. And it's all at a student-friendly price that costs less than a mid-tier restaurant meal. Not even steakhouse level, more like a fancy burger with just one side. See you inside the ebook course.